Went fishing, got burned.
Got a tick.
Oh yeah, we found a tick. Yeah, I was talking to Scott about it, but we found a tick.
What, a tick on you?
Yeah, I was going to the washroom, had my pants down, and like it was on my leg. It hadn't like burrowed in yet, but I just like flicked it off, and then it was somewhere in our bathroom. And so we were looking for him. Michaela's like, "You're just making stuff up, blah blah blah." Then it was on her leg, and then she freaked out and like flicked it off her, and then we like found it, and then we killed it. But yeah, it's pretty nuts.
Oh man.
For like the whole night.
Yeah, I like threw all our clothes in the dryer. I was like, "You didn't lay down in bed, did you?" I was like,
That's
okay.
That's funny.
But yeah. It's crazy.
it froze up, Darren, but that's super scary, man.
Yeah.
Hey, I found, by the way, the Excel spreadsheet, the quantitative inference procedures. Basically has everything, the paired sample t-test, everything that this lesson goes over. So all you have to do is copy and paste, and probably should be good. So,
Okay.
shall we get started? Do you want to just go to the group meeting quiz?
Yeah, let's open it. I have it open.
This lesson, as I was sitting here for the last, like the last little bit here, I was looking over the lesson. It looks really easy, to be honest with you.
It was pretty easy.
So, as long as you're good with addition and subtraction, really just subtraction, I think you're safe.
Yeah.
So, let's go to the group meeting quiz.
Brother Ben, if you're watching, I apologize. I've been so wrapped up in my weekend that I did not prepare as much as I should have. So, or Adam, Anyways.
It's his birthday. Give him
Great.
Yeah, it's his birthday. Come on, give him
Come
an
on,
A.
Brother Bennett. Give me an A on the next exam. That'd be great. Okay, man, cool.
Okay. All right, let's see. You'll need the following data files. Whatever, I'll get to it when I get to it. All right. So is everybody there?
Yep.
Yeah, number 3, what is the value of the test statistic?
Yep. Suppose we have a set of paired data and let the difference equal x after minus x before. The null hypothesis is that the sample mean.
Mu.
Okay, it's mu, but I'm trying to like spell it out so I understand like what's going on. The sample mean difference equals 0.
So it's saying that x after and x before are the same.
Yes. So that there's no difference. And somebody's saying, oh, but there is a difference. And the population standard deviation is not known. Jordan collects a sample size of 9 and computes the difference 2.2 and the sample difference 3.3. What is the value of the test statistic?
2.
So, why 2?
Because it's 2. So D is 2.2, and then the sample D is 3.3. So there's only 2 like test statistics.
Is that it? What's the value? Is that really all it is?
I think so.
Just 2?
Well, that is interesting. Okay. Test statistic. Oh, here we go. Just have to make sure. Well, whatever. I'll put 2. If it's wrong, I mean, we get another chance. So, 2.
2 more chances.
Oh, yeah, true. So really, that's it? 2. Is it 2 because of the 2.2 and the 3.3?
I think so. It's because there are 2 computations.
Okay. So the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use the probability to determine the p-value for Jordan's hypothesis test. Okay. 0.0403.
I'll be right back.
Okay.
Okay, cool. Michaela, take his place.
Michaela, tell him what's up.
Michaela's just busy doing homework.
Yeah, I'm so busy. I did a microbiology midterm today.
Michaela,
Nice.
I forgot to tell you the other day your makeup was on point, just as someone who observes those things.
Thanks.
In case Darren didn't say anything, just covering the bases.
That's funny.
He usually tells me, but you must have a wife that really likes makeup because it's only the husbands that have wives that like makeup. Notice.
My wife does enjoy makeup. And then a while back I had a friend who was a girl, but if I say girlfriend, it sounds like I dated her. I had a friend who was a girl who worked for Sephora. And
Oh,
so she would just like constantly tell me things, and like after like going through that for so long, you just don't really unlearn it,
Yeah, like contouring and highlighting and
Exactly.
Darren knows all that stuff. He's done my makeup before.
it was hot.
Darren, are you serious?
She legit looked like a raccoon.
Black eyeshadow all over
Dude,
my eyes.
that's so awesome. You tried though, man.
Yeah,
That's funny.
He tried.
I have to keep trying until I get good at it.
Yeah.
Cool.
Okay, so, where was the question? Okay, the p-value. Determine the p-value for Jordan's hypothesis test with 0.043. Okay. Why do I feel a little
Scott,
rusty
are
on
you
this?
able to send me that Excel spreadsheet?
It's on the website. It's on
Okay,
the.
good.
Here, let me see if I can find it. Yeah, there it
Awesome.
is. Here. Okay, go there.
And is our homework due tonight as well?
Yes, it is.
Oh my gosh.
Wait, is the homework due tonight? I don't. No. The homework's not. Sorry, I thought no. The group quiz is due tonight. The homework's not due till Saturday.
Oh really?
Oh,
Okay, great.
Yeah.
Let's
So
speed
that's.
up a little bit.
Yeah.
Uh,
Okay, so what is the
test statistic.
determine the p-value for Jordan's hypothesis test when the test statistic is 0.0403? Do I have to plug that into the Students T probabilities app?
Yeah,
Okay, with 8 degrees of freedom, right? Because n equals 9.
Yep.
Okay, and it's the area shaded to the left, which would be 0.5155, or is it point?
greater. So the other way.
Oh, it's the other way. So 0.4845, right? I thought it was the statistic shaded to the left.
Well, it says the probability of obtaining a test statistic greater than Jordan's. Right?
Right. Yeah, I could see that. Okay. Greater. All right. So it would be 0.4845. So 0.485.
Cool.
Okay, use the data file, chapter 12, data A1. Will do to answer the next 6 questions. Okay, this should be easy. Copying and pasting it into that other sheet. Okay. So now it says, what is the test statistic? 0.407.
I got 0.407.
Okay.
The next one I got 0.689.
Hold on. Where the heck is my dang sheet? Here we go.
Awesome, Darren. I got the same thing.
Cool.
Okay. The next one was what? 0.689, right?
Yeah, sorry. 0.689.
Okay.
And then fail to reject the null, right?
What's the? It's 0.10. So yeah. If it's less than the level of significance, do you fail to reject the null?
Yeah.
Okay. Suppose your alternative hypothesis is instead less than 0. What is a correct decision based on this evidence?
It cut out. What'd you say, Scott?
Oh no, I'm just saying. Suppose your alternative hypothesis is instead less than 0. What is the correct decision based on this evidence? Less than. Wait a second.
I think we have insufficient evidence that the mean of the differences is greater than 0. Because we failed to reject the null.
Wait. Hold on a second. Okay, not equal to 0. And then this one is greater than 0. So let me plug that in real quick, though, because it changes it. Greater than, the p-value becomes 0.34, so it would be the same thing. Because if it's the same test, and instead of testing for is it not equal to 0, you're instead testing is it greater than 0, then you just go to that paired sample t-test for means and change the not equal to the greater than, the type of test. And it changes the p-value to 0.344387179. So that should be sufficient evidence.
Sufficient evidence?
I thought so. Whoa, wait a second. This isn't rejecting or any sort of hypothesis. So suppose your alternative.
You have to do group 1 minus group 2, right?
Yeah. And then the difference is in there, and then you have the variable 1 and 2, and then the type of test is greater than. And the null hypothesis is 0.
Okay. I don't.
You see what I mean?
I don't think so.
What do you mean?
I just don't think that there's sufficient evidence because if you fail to reject the null hypothesis because of lack of significance, how can you determine that the alternative hypothesis of the mu of D is greater than 0 based on the data that we collected?
It's the same test, except for instead of not equal to 0, it's greater than.
And what value did you get?
The p-value is 0.344387179.
Okay, yeah, I see what you're saying.
I think that would give us sufficient evidence, right? It's just changing the test. We have all of the evidence we need up above, and it's all using the same information. It's
Yeah.
just instead greater than. So we have sufficient evidence that the mean of the difference is equal to 0, right?
Mhm.
Because it doesn't pass the levels of significance. I think it's D. I guess we'll find out.
I think it's N.
What?
I think it's N.
N. Okay. I'll put N.
So guys, we're doing the sufficient evidence that the mean of the difference is equal to 0, and then N as well.
Huh?
I got N
Oh,
as
are
well.
you talking about question 9?
Yeah.
Oh, okay. Yeah, N, of course, because degrees of freedom is N minus 1, so N is always greater.
Yeah.
Okay. What's the p-value? Let me download this new one. Okay. What is the p-value? And we're looking for not equal to 0. 0.999392344.
Isn't it 1 minus that?
What are you talking about?
Sorry.
The p-value here is... Whoops. Did I say less than? Whoops, sorry. I messed up. The type of test I put less than, I meant to put not equal to. So yes, it's 0.0012. Yeah, you're right. It would be 1 minus that.
That's what I got.
I did it the wrong way. 0.001.
That's what I got. What did you get, David?
Guys, I didn't do that one. I'm not gonna lie to you.
Okay.
Levels of significance, so it's...
You'd fail to reject it again?
Yeah.
Okay. Why is it... Okay. You decide to try another alternative hypothesis. This time you use whatever greater than 0. Does the p-value increase or decrease?
Well, it decreases, it halves, because...
Yeah, it
Like
decreases.
before you had anything that's not 0, and now you only have things that are greater than 0. Right?
True. Yes.
Decrease.
Yep.
What decision do you make? Reject the null hypothesis again?
Based on your response from the previous question, what conclusion do you make? We have sufficient evidence that there's
That
no
there's a
mean difference.
Wait. We were
There
rejecting
is a
the
mean
null
difference.
hypothesis.
Yeah, reject the null hypothesis. Yeah.
Okay.
13. That there's sufficient evidence that there is a mean difference between the two groups.
Yeah.
I didn't even read the question.
We have
And also,
insufficient.
someone typoed it. Every one the other ones say groups, and that one says group.
Oh yeah. It must be correct.
I see.
So as we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? It's going to be the greater than 0, right?
Well, less than 0 is the same as greater than 0, because it's...
But when I did less than... But when I did less, so when it's greater than 0, it's 0.0006.
That depends on the value that you give it.
What do you mean?
Like the inputs that you give it, like what the sample size is, what
Right.
the data is. So I don't think you have enough
Oh, in
information.
general. I see what you mean. In general.
Yeah.
Okay. Yeah, because when I was doing less than, of course, it was the 0.999 whatever, which is like way higher. But so just
Yeah.
not enough information depends on the problem.
Yeah.
Okay. Determine the 95% confidence interval for the mean difference between the two groups.
I got 11.955.
The 99% confidence interval.
95.
11.955, Darren.
Yeah.
You're looking at the mean of the difference? Oh, the
The
point
point.
estimate. Yeah, duh. Yeah, okay. Yeah, 11.955.
And the margin of error for the 95 is 6.652.
Okay.
Hold on. I know margin of error is somewhere around here. Where do you see 6.652?
You can hit the light low. don't think so, babe. I think it's. Oh, it is. There you go.
Where do you see the 6.652?
Yeah, let me pull it up.
It's a z-score. Okay.
Yeah, we just divide the standard population deviation by the square of the sample size, and then you multiply by,
The z-score, or t, I guess, in this case.
yeah.
Does it not pop it out automatically on in Excel?
I didn't find it.
Because I thought standard error of the mean is the same as the standard deviation, or the no, that's the standard deviation. I don't know what I was thinking. Okay, hold on. I got this. I'm gonna add a new section now onto this spreadsheet just for this margin of error. Margin of error.
So we are sticking with the 6.652.
Yeah, give me a sec. Equals that divided by the square root n, which is 22, times the z-score, or t in this case. What did I get? 2.548? Do you have it, Darren?
Yeah, let me just input these other two. We'll submit. Okay. 5.33. 18.604. All right, so I am submitting now.
Oh, you just did the whole thing.
Yeah, I just submitted the last three.
Okay.
He's a
Okay,
champ.
100.
Okay. You're gonna have to show me how you got that one then, because that doesn't make sense to me.
So just to go over the thing, Darren, what'd you get for 18 and 19?
Oh, 5.303
18.607.
and then 18.607.
And 17 was what?
6.652. So all I
Why
did was
did
I
I-
found the margin of error, and then I just added it and subtracted it. So that's how you get the lower bound. Is you just take
Right.
point estimate for the 95% confident interval minus the 6.652 gives you your lower bound, and then add it to the 11.9.
Oh, wait a second. So all I really had to do to find the margin of error was to take the point estimate of the difference and subtract, say, the lowest confidence level.
Yep.
That's
No,
it.
subtracted from the point estimate.
Yeah, that's
Oh, sorry.
it's the point estimate minus if you do the lower bound.
Yeah, to get the lower bound, yeah.
Well, what the heck? How did I come up with 2.548? Because what I did with mine is I did the T score, which is 3.737, multiplied by the standard deviation or the standard error of the mean, the difference, which is 3.19